So we're going to rewrite our definition of our derivative. So in this question, it's asking for this notation. So we're just switching between different notations. And our definition has f of x plus h minus f of x over h. Of course, we don't have function notation here, but f of x is just another way of saying y. So what does this look like? dy dx. Oh, this is going to be a good one. H goes to 0. F of x plus h would be 2 times x plus h cubed plus 4 times x plus h. Minus, I'll put, since we're minusing f of x, I'm going to put big square brackets there because you have to minus all of f of x, which is 2x cubed plus 4x, all over h. So those square brackets mean that that minus sign has to be distributed to both of them. And the first thing we look at when we're going to do our algebra here is we have x plus h cubed. So I'm just going to go to another page just to think about that. What does x plus h cubed mean? It means x plus h times x plus h times x plus h. Are we happy I didn't have x plus h to the 15? Probably. So we could use our skills from grade 9 and 10 to multiply this out. When you have 3 things multiplied, you multiply 2 of them first. X squared plus 2xh plus h squared, still times by x plus h. And then you would have to distribute all of those and get x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed. And combine all your like terms, x cubed plus 3x squared h plus 3xh squared plus h cubed. Whew! So I did that off to the side because that would be a lot of math steps to rewrite the limit thing over and over again. Okay? And for those of you that have studied Pascal's triangle and the binomial theorem, there's Pascal's triangle, the first 4 rows. The fact that we have an exponent of 3 means that in the expansion we're going to get 4 terms, just like we saw there. And those 4 terms are going to have coefficients 1, 3, 3, 1 that match up with Pascal's triangle. There we go. Make it smaller. And so we'll have 1x cubed plus 3x squared h plus 3xh squared plus 1h cubed. So you could use Pascal's triangle to expand that as well. Whichever way you expand that, we can now go back to our limit and say dy dx is equal to the limit as h goes to 0 of 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed plus 4x plus 4h minus 2x cubed minus 8x. All over h. And this 2 is going to get multiplied through to each of those. Oops, I had a little typo here, sorry. That's a 4. That's not a 4 anymore. I don't know what happened. That should have stayed a 4. That looks better, right? This negative sign, when I distribute it, that 4 should have stayed a 4. First of all, can you see that the 2x cubed here is going to subtract with that 2x cubed and go away? That this 4x here is going to subtract with that 4x and go away. And what we're going to be left with on the top is limit h goes to 0 of 6x squared h plus 6x h squared plus 2h cubed plus 4h. Again, our goal for a limit is to do something to get rid of that h on the bottom, because then we'll be able to evaluate. Now can you see in our numerator that I have an h in every single term? So I could factor it out, leaving me with 6x squared plus 6xh plus 2h squared plus 4 all over h. So my h's cancel out. And after all of that, we can now apply the limit. We can plug in 0 for h. And the only thing we would be left with is 6x squared plus 4. Look at all that beautiful algebra. And those that have already done some calculus already, I'm going to tell you that you can do this in under 2 seconds. By midweek next week, you'll be able to do this question in less than 2 seconds. But in this case, using the definition of the derivative, this is what we'd have to do. So we're going to learn a shortcut that can reduce this question to taking only 2 seconds. Yes? Yes, on the quiz you'll have to do this. You'll have to show all of the definition and the limit. So notice how I expanded this off to the side for x plus h cubed, just so it would be somewhere else. Now the reason I wanted to show you this example with the derivative is you had to substitute the x plus h wherever there's an x, right? That's how function notation works. So sometimes students get stuck when there's more than one x. They're like, I don't know what to do. Well, it still works out to be the same idea. Same thing here on our last example. We'll write out our definition. Again, you have to have your definition of your derivative memorized. So that's the first step, is to be able to write that out. And then plug it in. So x plus h will be x plus h plus 2 over 2 x plus h minus 1 minus f of x is x plus 2 over 2x minus 1 all over h. And here we get to work with our skills with fractions. So how do we have, if I have an equation with fractions inside of fractions, can I use my algebra skills to get this to be a single fraction? And if I can use my algebra skills to get this to be a single fraction, then chances are things are going to work out that I can cancel that h out. So first of all, to get something to be a single fraction, it makes sense. Can I make my numerator one fraction? Can I add those together? How do I add and subtract fractions? I need a common denominator. So in my numerator, I've got 2x plus 2h minus 1 and 2x minus 1. So if I was going to get a common denominator, can you see that this first one would need to be multiplied by 2x minus 1 and 2x minus 1. And this one is going to need to be multiplied by 2x plus h minus 1 and 2x plus h minus 1. What does that do? Okay. I like to make, see how this is my main dividing line? I like to make my main dividing line either longer or thicker or something so I remember that that was my main dividing line. And then now up here, that one's a little bit shorter to show that I've got 2x minus 1 multiplied by, I'm going to just distribute that, 2x plus 2h minus 1. And in my numerator up here, if I multiply these together, what am I all going to get? I'm going to get 2x squared plus 2xh plus 4x minus x minus h minus 2. I have the advantage to slide that over when I start running out of room. Subtract distribute that 2 right away. And now I'm going to subtract bracket. If I multiply this out, 2x squared, okay, 2x squared plus 2xh minus x plus 4x plus 4h minus 2. Whew. Initially, this feels like maybe we're going down the wrong track because it seems like I'm writing a lot of stuff. But now that I've expanded that, can I simplify my numerator at all? Limit as h goes to 0. Big line, h. Well, 2x squared, remember this minus sign is going to get distributed to all of those. Can you see that your 2x squared and your minus 2x squared are going to cancel out? And I'm going to have a 2xh and a minus 2xh. Those are going to cancel out. And I've got a 4x minus a 4x. Those will cancel out. A minus x minus x. Oh, this is looking exciting at this point. A negative 2 minus a negative, oh my goodness. And I get a negative h minus 4h. There's our difference. So my numerator just becomes negative 5h. Yes? Any mistakes in my math? Not that any of us noticed? What's that? I get the 2 minus the negative 2 is negative 2, but that cancels out with that negative 2. So I just get 5h, and then this is all over 2x minus 1 times by 2x plus 2h minus 1. Things are going to get really nice here. Because if you're dividing, if you have a fraction in your numerator divided by something, this h is like h over 1, what are our fraction rules for dividing a fraction by a fraction? Multiply by the reciprocal. So if I do that at this case, at this time, limit as h goes to 0, I have negative 5h over 2x minus 1 and 2x plus 2h minus 1 multiplied by the reciprocal 1 over h. And that h, which was causing a problem, now simplifies. And once I get rid of that h, can I plug in 0? Yes. And I'm left with just a negative 5 on the top and 2x minus 1 times 2x minus 1, so I'll write that as 2x minus 1 squared. And that will be our derivative function. So if we zoom out again, okay, this question for our shortcut method coming up later, this one's going to take us at least 25 seconds. This is a harder one with a shortcut. Ooh. But it will still be much faster than this. So last class, I gave you a practice sheet for derivatives. And we've also got questions in our textbook. There's a number of people missing, so I'm not going to start the next unit today, but just give you time to practice using the definition. Okay?